We're just going to do a quick video of four problems that we're going to work through from the book, the honors book, dealing with torque. The first one, we have the wheel of a car has a radius of 0.35 meters. The engine of a car applies a torque of 295 newtons meter to this wheel, which does not slip against the road surface. Since the wheel does not slip, the road must be applying a force of static friction to the wheel that produces a counter torque. Moreover, the car has a constant velocity, so this counter torque balance is the applied torque. What is the magnitude of static frictional force? Okay, so let's focus on the main things. They give us the radius, the torque caused by the engine, and there's going to be a counter torque caused by the friction, giving the torque 0. Now, torque is how quickly the centripetal, the circular acceleration is. A net torque of 0 means that this wheel is not accelerating, it's turning, but it's still turning like we did with a constant velocity. Just because you have an acceleration of 0 doesn't mean you're not moving. Just because your torque is 0 doesn't mean you're not rotating. You're just rotating at a constant speed. So here's the engine is causing this torque. We decided to make it negative based on how I drew it, because the static friction is the force pushing the car forward. And since the static friction is going to be creating a positive torque, I made the torque of the car negative, but you could have drawn yours differently. Since the acceleration is 0, that's also the tangential acceleration, so it means the car is moving at a constant speed. Since there's no slipping, the tangential acceleration and linear acceleration are the same. Tangential acceleration is the radius times the angular acceleration, which means the angular acceleration is 0. Remember, torque is proportional to the angular acceleration, just like net force is proportional to the linear acceleration. But that's not really what we need to solve the problem. So, alright, to solve the problem, we just pretty much use the net torque equation. The net torque equation is just the sum of all the torques. So there's a torque caused by the engine, which is negative 295, plus a torque caused by friction, which means the torque caused by friction has to be positive 295. And torque is the force times the linear distance from the center of rotation. And since the distance from the force and the linear center is perpendicular, we don't have to worry about sine because it makes a 90-degree angle, and that's 1. So simply we just take the force of friction times the radius, which is 0.35, times 1 is equal to 295. So we solve that equation. We figure out the force of static friction must be 842 newtons, which does sound like a lot, but at the same time, this is a wheel of a car, so it is producing a lot of force. It's moving very, very fast. That's it.